Attacks can come from the internet or the internal network. And as such, they all come through the network and therefore can be monitored with Wireshark. The packet sniffing process involves some efforts between software and hardware. This process can be broken down into three steps. The collection is the first step, where the packet sniffer collects raw binary data from the wire. Typically, this is done by switching the selected network interface into promiscuous mode. In this mode, the network card can listen to all traffic on a network segment, not only the traffic that is addressed to it. The second one is conversion. In this step, the captured binary data is converted into a readable form. At this point, the network data is in a form that can be interpreted only on a very basic level, leaving the majority of the analysis to the end user. The analysis is the final step that involves the actual analysis of the captured and converted data. The packet sniffer takes the captured network data, verifies its protocol based on the information extracted, and begins its analysis of that protocol's specific features. Before starting with testing your client's network, you need to make sure that you have an updated topology of the network that includes servers' IP addresses and LAN's IP address ranges, routers, switches, and other communications equipment, security devices like firewalls or intrusion detection systems or intrusion prevention systems. Also, you need to know what are the applications that work over the network, including TCP or UDP port numbers and IP addresses. Finally, you should use the internal network scan that you already saved during the previous module. When you monitor internal traffic in your organization, you should be able to differentiate between normal traffic and a suspicious one. Here's some practical examples. So, a traffic from known addresses is a normal traffic, but you should be careful when the traffic is coming from addresses that you don't know, right? A normal traffic includes standard port numbers like 80 for HTTP, 21 for FTP, 25 for mail, and so on and so forth. Be sure of the applications that run over the network and verify that these are the only port numbers that you see. Also, a normal TCP pattern would be something like SYN, ACK, and then ACK, the three-way handshake, that indicates a connection establishment. A suspicious one contains a large amount of SYN packets that go to a single host or coming from multiple sources. Also, unusual flags, combination like reset, fin, urge, and so on. Now here's the trick. Normal traffic patterns are usually not of fixed bandwidth. So normal activities when you save or open files, browse the internet, send or receive emails, all these kind of activities, you see ups and downs. You should get suspicious when you see fixed bandwidth patterns that indicate someone is connected to your device or watching video in some cases. When you see a fixed bandwidth pattern of traffic, check what it is. Now, when you see tens, hundreds, or thousands and more broadcasts per second per device, you should check it right away. Finally, A standard DNS query response pattern up to several tens per second per client occasionally is considered normal. But massive amount of DNS queries and responses are not. Now here's a list of common attacks that can come from the network. We have malware, denial of service, man in the middle attacks, all types of scanning, brute force attacks, and application layer attacks. In the upcoming demos, we will see how to analyze most of these attacks.